Okay, so today we are discussing rotational motion. So, rotational motion is simply a motion in which all particles of a body perform a circular motion about a fixed point. So, there is a fixed point about which all the other points are performing a circular motion. Let's say here is a rod and we are moving this rod in the vertical direction, okay, 90-degree upwards. So, every point of this rod is traveling about this fixed point. So this rotation, this motion of the particles is called rotational motion. Okay, so now there are some quantities like angular quantities. So we are going to discuss them, which are used in the rotational motion. In the next upcoming videos we will also discuss other things like torque and moment of inertia, which will be these quantities will be helpful for those videos as well. Okay, so now discussing the first angular quantity, which is angular displacement. So it is a very basic and a simple quantity which tells us that, like, if we are moving in a circular path, let's say like this, from here to here, okay, so we have covered this distance. Okay, let's say we have covered this distance, so let's say this distance is s. Okay, so this is a linear displacement. Okay, so body moves from here to here. But what about this angle subtended by a body? Okay, so this angle subtended by a body is called angular displacement. How much angle is subtended from the initial position to the final position from the center of the circle. So this is called what? This is called angular displacement. So it has a unit, it is usually measured in radians. Okay, so here is also a relation between the linear displacement and the angular displacement, which is s is equals to r theta. Okay, so now moving toward the next quantity, which is angular velocity, which is represented by omega. Okay, so omega is represented by w. So here is another figure used to demonstrate what is actually angular velocity is. Okay, so it is like same like a velocity, linear velocity, which is rate of change of angular displacement. Okay, so in the linear velocity we have rate of change of linear displacement, and here we have rate of change of angular displacement. So we can write the angular velocity has a formula like this: omega is average. If we have to find the angular velocity, average angular velocity, so we will use this formula, delta theta divided by delta t. And if we have to use at a particular instant that what is the angular velocity at a particular point or a particular instant, so we will use d theta upon dt formula. Okay, so it has a unit radians per seconds, and it has a relation with the linear velocity, which is v is equals to r omega. So that's all for today. In the next video we will see how the angular acceleration and tangential acceleration are different